In this video, we will be talking about number systems such as octal number system, then hexadecimal number system, then conversions. Conversions means we studied 4 number systems, right? Decimal number system, binary number system, octal and hexadecimal. So conversion from decimal to binary, binary to decimal, octal to decimal, hexadecimal to decimal. These conversions, 4 conversions also we are going to study. So first we will look at the octal number system. So in an octal number system there are 8 digits. The digits from 0 to 7. Okay, 0 to 7. No other digits 0 to 7 are used. So hence the base of the octal number system is 8. Okay, so since 8 digits are there in the octal number system, the base is 8. Some examples are 527, 45, 64. Here only the digits between 0 to 7 or including 0 and 7, those numbers are used. Okay, so this octal number system, what was the application of octal number system? So it was widely used in computing when systems such as Univac 1050, PDP 8, etc. Those were old computers, old computing machines. In those type of computer machines only octal number systems were using. Okay, their application was there. Now we are using completely binary number system. Okay, most efficient in computers now. Now we will go to the hexadecimal number system. In hexadecimal number system there are 16 digits. So binary 2 digits, decimal 10 digits, octal 8 digits, hexadecimal number system 16 digits. So here there's a little bit confusion, or not confusion, you may feel weird here. Actually we are telling digits but we are using letters also. So these 16 digits is a combination of 0 to 9 digits plus A to F letters, A, B, C, D, E, F, A to F letters. Here 0 to 9 normal digits are there, but in the case of 10, 11, 12, 13, 14, 15, these numbers are represented by A, B, C, D, E, F respectively. So 10 is represented by A in hexadecimal number system, 11 is represented by B in hexadecimal number system, and likewise it will go up to 15. So these hexadecimal numbers were used by computer system designers and programmers. Okay, computer system designers and programmers. So some examples are given here. 54A. So it's actually, instead of A it is actually 10, but instead of 10 we are using A. So 54A, 65A, 4D2. Instead of D it is 13 actually, so it is 4132 actually, but 4D2 it is used like this. Now we will go to the conversions. So the first conversion is decimal number system into binary number system. That means base 10 to base 2. Okay, base 10 to base 2. So the steps for conversion. First one, divide the given number by 2. So whatever number, whatever decimal number you have given, you should divide it by 2 continuously down. Okay, and after dividing first time, you have to write the remainder on the side. So if the number is like for example 5, you should divide it by 2. That means 2 into 2, 4 you will get. The remainder 1 is there, so the remainder you have to write on the side. Quotient is 2 again. Okay, and these steps, this dividing by 2 and writing the remainder, you should repeat until you get a 0. Okay, until you get a 0. So there's a typo here, sorry for that. Yeah, now so after dividing it until you get a 0, step 4, that is write down the remainders. So you are dividing it in a special way. Okay, I will show that in the board. I will show that. So After dividing all, you write down the all remainders together from bottom to top. Okay, take all the remainders from bottom to top and write it down. You will get the binary number of the corresponding decimal number. Okay, so that's how you will divide, you will convert decimal number into binary. In this video we are going to study about converting decimal numbers to binary number system. Okay, so as you already know, decimal number is base 10 numbers and binary number is base 2 numbers. Okay, so the conversion is from base 10, okay, base 10 to base 2. It's written like that. Okay, base 10 to base 2, base 10 to base 2. So your questions will be coming like this. For example, 25. So convert 25 10 to dash 2. Okay, it represents convert 25 of base 10. Base 10, then you have to think it is decimal. So base 10 to base 2. So this way the conversion questions will come. Okay, so we will do the conversion now. So as we already said, we have 25 10 to 2. This we have to find out. Okay, this one we have to find out. Now according to the steps we already discussed, we have to write down the 25. We have to write down the 25. Division. Now we have to do the division. Continuous division with 2. Continuous division with 2. Okay, so 2. 25 divided by 2. So already you know 12 into 2 in the table. 12 into 2 is 24. So here the quotient 12 into 2 24, but 25 is there, so remainder is 1. Remainder means 25 minus 24, it is 1. So we will write the remainder here. Now again this 12 will be divided by 2. So you know that which number into 2 is 12? 6. Yeah, 6 into 2 is 12. So here no remainder. 12 minus 12, 0. So no remainder, then it is 0. Again divided by 2. Okay, again divided by 2. So 3 into 2 is 6. So you can write the 3. 3 is the quotient. Okay, 3 into 2 is 6. Here also no remainder, so you can write 0. Again 2. Here 2 ones are 2. Okay, so 2 ones are 2. 3 minus 2, 1. Remainder 1. Okay, so you got like this. So these all are remainders. Okay, these all are remainders and these are quotients. Okay, these are quotients. This is the divisor. Okay, so here now according to the step we already did, we continuously divided it by 2. Okay, now you cannot divide it further. Okay, you cannot divide it further, so you got the answer there. Okay, 1 here, here. Now you need to write down these numbers from bottom to top. Write down these numbers from bottom to top. Okay, from bottom to top you have to write. That means in order from here to here. Okay, so we will just write the answer here. 1 1 0 0 1. So 25 means 1 1 0 0 1. Okay, that's the corresponding binary number. Okay, we will just look into another example also. You can do any digit numbers here. Okay, so if it is 4 digit 3 digit number, then its conversion will go low. That's all. Okay, so here we will go for another number like 45 10 to base 2. Okay, so what we need to do? 45 divided by 2 continuously 2. Okay, so here 22 into 2 is 44. 22 into 2 is 44. 45 minus 44, 1. Remainder is 1. Again 2. 11 into 2 is 22. So 22 minus 22, there is no remainder, so 0. Again 2. Here you know that 5 2s are 10. 11 minus 10, 1. Remainder 1. Again 2. 2 2s are 4. 5 minus 4, remainder 1. Again 2. 2 1s are 2. 2 minus 2, remainder 0. So no remainder. Now we have to write from bottom to top in the order 1 0 1 1 0 1. Okay, I hope you understood this. This is a conversion of decimal to binary number system. Now for your practice, I will give you some questions. You have to do it. Okay, so the questions are practice questions. This is base 10. You need to convert to base 2. Okay, then this is not binary number, this is 101 decimal number. Okay, so this decimal into binary, what will be the binary, you have to find out. Okay, yeah, 3 practice is enough, so do this problem. Okay, now binary number into decimal, we did this one yesterday. Here base 2 to base 10 conversion. Here instead of division, multiplication is used. So here multiply each digit of the number with its positional value, like 0 1 2, that values you may remember that, which is in terms of powers of 2 raised to 0, 2 raised to 1, like that, starting from the extreme right digit. Then increase the power 1 by 1, keep the base fixed at 2. After multiplying all the digits together, then you will get some products. So add the products together, you will get a number, that will be your decimal number. Okay, when I do it in the board, you will understand more. Yesterday we did that, but one more time we will do that. Hi, here this conversion is we are converting from binary to decimal. That means base 2 to base 10. Okay, how to convert we are going to study. Here there is no division, but there is multiplication. Okay, so here we are going to study base 2 to base 10 conversion, that is base 2 to base 10. Okay, here the numbers will come. So we will take an example, a binary number 1011. A binary number is here. This is a binary number. We need to convert it back to decimal number. So how to convert? First of all, we need to write down the binary number. Just give some space, 1 1. Okay, 1011. So its positional values 0 1 2 3. That is a positional value. Now we have to write down the exponent value, which means according to the base 2 we have to write, that is 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3 for each digit. Now we have to multiply this with this, this with this, like this we have to multiply and add all the products together. Okay, we will just do that. First we will take this position, we will start from this position only. Okay, we will start from the first position, this position. So 1 into 2 raised to 0. Next is 1 into 2 raised to 1. 1 into 2 raised to 1. Next is 0 into 2 raised to 2. I am writing here, okay, because of the space. Here equal to 0 into 2 raised to 2. And 1 into 2 raised to 3. 1 into 2 raised to 3. So these all things we need to find out. Okay. So already in the previous class I said any number raised to 0 is 1. So 1 into 1. So 1 into 1 is equal to 1 is the answer. 1 into 1 is equal to 1. You got a 1. Then 1 into 2 raised to 1. 2 raised to 1 is 2. 2 raised to 1 is 2. So 1 into 2 is equal to 2. Another number you got Then you got 0 into 2 raised to 2. So 0 into 2 raised to 2 is 2 into 2, that is 4. But 0 into 4 means it is 0 itself. Now 1 into 2 raised to 3. Okay, 1 into 2 raised to 3 means 1 into 2 raised to 3 is 8. So how 2 raised to 3? 2 raised to 3 is equal to 2 into 2 into 2, that is 8. 2 into 2, 4, 4 into 2, 8. Okay, already I said, but for your understanding I said one more time, that's all. Yeah, so here 1 into 8 is equal to 8. Okay, now you got 4 numbers here, 8, 0, 1, 2. Add these numbers together. Okay, so we will just add it. 1 plus 2 plus 0 plus 8. 8 plus 2, 10. 10 plus 1, 11. So the number is 11. The answer here, we got the decimal number 11. So that is binary to decimal conversion. Okay, so if we need one more example, we will do, no issue. Yeah, one more example. Number 1 1 1 triple 1. Okay, if it's not triple 1, 1 1 1. Yeah, same way, 1 1 1 0 1 2 positional values. Now we have base is 2, so 2 raised to 0, 2 raised to 1, 2 raised to 2. Now multiply this like this, we have to multiply. Okay, so 1 into 2 raised to 0, 1 into 2 raised to 1, 1 into 2 raised to 2. 2 raised to 0 is 1, so 1 into 1, 1. 1 into 2 raised to 1 is 2, so 2 into 1, 2. Then 2 raised to 2, 4. 4 into 1, 2 raised to 2, 4. 4 into 1, 4. So the answer here is 1 plus 2 plus 4. That is 4 plus 2, 6. 6 plus 1, 7. So the answer is 7. So this is 7. Okay, I hope you understood the example here. So this is binary to decimal conversion. Now octal number system into decimal number, that is base 8 to base 10, base 8 to base 10. Same way you have to multiply each digit with powers of 8. Okay, powers of 8 means positional value which is in terms of powers of 8, like 8 raised to 0, 8 raised to 1, 8 raised to 2. Only 8 you have to use and multiply it with the numbers. Okay, then increase the power. Then after that all the products you have to add together, you will get the decimal number. That's another conversion. Okay, I will show the example. In this video we are going to study about the conversion of octal to decimal number. So octal number to decimal number. So as we already know, octal number is base 8. That means 8 digits. 8 digits means 0 to 7. Okay, so this is the property of octal number. It is base 8. That means 8 digits, 0 to 7 digits are used. Okay, 0, 1, 2, 3, 4, 5, 6, 7. So this is an octal number, but this is not an octal number. This is a decimal number because 9 is included here. Okay, 9 is not in octal number, so this is a decimal number. Okay, this is a decimal number. So here for octal number only 0 to 7 are used. Okay, so that is a property of octal number. Now we will take the conversion. So usually in question papers, if for example you have in question papers it is asking that 292, convert 290 to decimal. So you will not understand what is this, right? Base will be always written. If this is written like this, if 292 is written like this, that means it is base 10. It is a decimal number. Okay, 292, 10 is a decimal number. Or otherwise, for example, 242. You don't know whether it is octal or decimal. For that you will get this bracket and plus 10, this 10 here. So this 10 represents this number is decimal. Okay, so if instead of 10 there is 8, that means it is not decimal, it is octal number. So you have to identify with this. Okay, if base is not given also it is identifiable. Already I said only the numbers from 0 to 7 will be in the octal list. Okay, yeah. So now we will do a base 8 to base 10 conversion, that is base 8 to base 10. Okay, so a number for example 242 we will take base 8, 242 base 8 to, we need to find out the corresponding decimal number. So in octal it is 242, we need to find out the corresponding decimal number. So how to do that? Same way as binary to decimal, take down the numbers 2, 4, 2, write the positional value 0, 1, 2. Now with the base you have to write like this: 8 raised to 0, 8 raised to 1, 8 raised to 2. Multiply with each number. Okay, multiply with each number. Now how to do that? First number you have to start from here: 2 into 8 raised to 0, 4 into 8 raised to 1, 2 into 8 raised to 2. Now we have to find out the calculation. Okay, this is a little bit hard because it is not 2, it is 8. Okay, so here we have 8 raised to 0. Any number raised to 0 is 1. So 2 into 1 is equal to 2. That answer we got, because 8 raised to 0 is equal to 1. Now 8 raised to 1, 8 raised to 1 is that number itself, that means 8. 8 raised to 1 is 8, so 4 into 8. And multiplication table, 8 4s are 32, yeah, 32. Now 2 into 8 raised to 2, 8 raised to 2 is 8 raised to 2 is 8 into 8. So multiplication table, 8 into 8 is 64. So here it is 2 into 64. Okay, 2 into 64. So that means 64 into 2, 4 2s are 8, 128. So 64 into 2 is 128, and 8 into 4 32, 2 into 1 2. So we got these three numbers. Now add these together. Okay, so 2 plus 32 plus 128. How to add? 32 plus 2, 34, 34 plus 128, 150, 160. Okay, 128 plus 2, 130, 130, 130 plus 32, that means 162. So the decimal number is 162. Okay, so 242 is the octal number, 162 is the decimal number. I hope you understood this example. We will go to one more example. Same conversion, base 8 to base 10, another number 156. So 156 base 8 to base 10, same way, 1 5 6 0 1 2, that is a positional value, 0th position, 1th position, 2nd position. That means 8 raised to 0, 8 raised to 1, 8 raised to 2. Multiply it. Okay, so how to multiply? 6 into 8 raised to 0, 5 into 8 raised to 1, 1 into 8 raised to 2. So 8 raised to 0 is 1. So 6 into 1 is equal to 6. Now 8 raised to 1 is 8. So 5 into 8. 8 into 5, 40. Multiplication table. Now 8 into 2 is 64. So 1 into 64, that is 64. Take all the numbers together. These three numbers together. 64 plus 40 plus 6. So here 64 plus 6, 70, 70 plus 40, 110. So the answer is 110. 110 of base 10. Okay, so that is base 8 to base 10. Okay, I hope you understood this example.